record this lesson and we go back to these chemical families. It was on which page? Page somewhere here. Good. So these are chemical families on page 82, isn't it?
Yes.
They're saying elements in the same group. Somebody is going to take over from there. Elements in the same group are referred to as chemical families because of the similarities in their chemical and physical properties. These elements in the same group have similar chemical properties because they have the same number of electrons on the outermost energy level. The common families are alkaline metals, alkaline earth metals, halogens, and noble gases. So since a question was there posed, alkaline metals are here. They belong to group 1 in the periodic table. These metals are very reactive and are kept under oil in the lab. There was a video here I wanted, but we saw that video one day of the last element in group 1 is what? The last element is in group 1.
Potassium.
Potassium. So let's look at potassium and then we compare potassium with other elements. Potassium reacts with air. I want us to look at this video carefully and you see what happens when you just expose it to air. So that is, they are cutting potassium. They said they are soft. We shall also look at that. That's why they usually cut them with a simple knife. You see how soft it is?
Yes.
As long as you chop it, the shiny surface comes in. So as we go down the group, the softer those things become. So this is first of all reaction with water. I'm going to show you potassium and then there is a frasium, reaction of frasium with water, and you see how they react. So here they are doing both. So this is for lithium, the way lithium reacts. Now, this video, this is for the color. Let me get for you the other one of so this is the reactivity of alkaline metals. You observe what is happening. They have removed one. So that is lithium. You see the way it is. Kept under oil, they are removing some oil from it, from the surface, so that it can react very well. So they are going to cut it with a knife. So you have seen the way this one is hard a little. That is the shiny surface. We are going to look at the physical properties of these metals. So after cutting, they are picking the drop and just put in water. Now, when you look at these properties, they are saying these metals are soft and can be cut with a knife. Okay? The softness decreases as you go down the group. You know, as you go down the group, they lose electrons because they lose electrons very fast. And that is what is responsible for the decrease in softness also. Then their melting and boiling points are low. Their melting points decrease down the group. They have low densities and they can float on water. They have shiny surfaces when cut. Have you seen this already there?
Yes.
The moment they cut one, you see that shiny surface. So the shiny surface tarnishes due to the reaction with oxygen. That shiny surface always tends to disappear as fast as it is because of the reaction with oxygen, as it forms oxides. So they are good conductors of electricity. They do not possess tensile strength. They don't have strong energy to hold it. So that tensile strength, the strength inside there is not so much. So it can easily be cut with a knife to an appreciable distance. So chemical properties are here. Reactivity of alkaline metals increases down the group due to increase in atomic size. Potassium is most reactive, followed by sodium, and then lithium is the least reactive in that group. Then reactions with the water. This is what they form. Please take note of this, that all metals react with cold water to produce hydrogen gas and alkaline solutions of metal hydroxides. The alkaline solutions maybe alkaline is, we shall look at them when you come to salts, but alkalines is when something has hydroxide ion in it, hydroxide. So if it is potassium, they form potassium hydroxide plus hydrogen gas at the end of the day. So that's what they are saying, that most metals react with cold water to produce hydrogen gas and the alkaline solution of a metal hydroxide. If the metal was sodium, at the end of the day, we must see sodium hydroxide plus hydrogen gas. Okay, that is the end product. So potassium reacts vigorously. That means it's very fast due on water and burns with a bright purple flame, producing fumes of hydrogen gas. That one, see, sodium melts into a silver ball on water, reacting vigorously and produces fumes of hydrogen gas. This reaction with water, all of them liberate hydrogen gas. That question was somewhere on this work here. We had that question somewhere. The melting points of this and this are that. That one we have looked at it. D forms two oxides. D, that is group 1. Now let's look at those oxides and we see reactions with air. When metals are heated in oxygen, they burn readily, forming oxides of metals. Potassium burns with that bright purple flame, producing white solids and potassium oxide, a white solid of potassium oxide. So the end product is an oxide there. Now, when sodium is burning, it produces two oxides. The conditions are when air is excess, if air is much, it burns with a yellow flame, forming yellow solids of sodium peroxide in plenty. If the air is little, sodium forms a white solid of sodium oxide. This is a bright yellow flame. A bright yellow flame followed by a formation of yellow solids of sodium peroxide if the air is plenty. What is the condition? The condition is air must be in plenty. Then we shall form sodium peroxide. Then if air is little, we shall form an oxide, sodium oxide. This one is white, a white solid. This one is a yellow solid. Now back to this question. The question is saying D forms two oxides. Is D sodium or another element? Yes?
It's sodium.
It is sodium. So in excess, it gives us a peroxide. In little air, it gives us an oxide. Okay? So those are the two reactions there. Then lithium, the rest behave the same way. When they react with chlorine, they all form chlorides, potassium chloride, sodium chloride. These equations are not balanced, so they need to be balanced. Reactions with acids, we shall look at acids like hydrochloric acid and sulfuric acid. When they react, they form salts of sodium chloride and hydrogen gas. This one, they form potassium sulfate and hydrogen gas. That is what they form. Now, look at the alkaline earth metals. Alkaline earth metals, we have left group one. Group one are called alkaline metals, isn't it?
Yes.
Alkaline metals. Group two are called alkaline earth metals. Now, let's compare the reactions of group one and group two. Here you see that these are elements in group two of the periodic table. They include beryllium, magnesium, calcium. These metals have 2 electrons on their outermost shell. They lose 2 electrons during the reaction to form a dipositive ion, an ion with a charge of 2+, that is a dipositive. The other ones form positive ion, this one form dipositive. So you see how they react. Magnesium loses 2 ions to get the 2 electrons to become the ion. Calcium loses 2 electrons to become a calcium ion. Even beryllium, that's what it does. Now properties, they are harder than group one. Therefore, cutting them with a knife might be hard. Okay?
Yes.
They are good conductors of heat and electricity. Even group one metals, they are good conductors. They are same color, silvery gray in color when cut, same as group one. However, shiny surfaces slowly tarnishes due to exposure and formation of a metal oxides. Even group one elements also behave that way. Their melting and boiling points are higher than those ones of group one because these metals release more electrons into electron cloud, forming a stronger metallic bond in a metal structure. This explains why they are harder than group one metals. So chemical reactions, they are less reactive. This one is not there, so take care in the book. So these alkaline earth metals are less reactive than the alkaline metals. This more, try and cross it out. It is less. They are less reactive. We have seen it from this point that they are less reactive than group one. That's the alkaline metals because they have more electrons to give out. So that is what is there. Reactions with air, they burn in air with a characteristic flame forming oxides of a metal. An example is magnesium burns in air with a brilliant white flame to form an ash of magnesium oxide. This is a white ash, magnesium oxide. Now, calcium burns with a bright orange flame. bright orange flame forming calcium oxide. Now, when you look at these two metals, they react with air in plenty and also in little. So here, both metals also form nitrides, especially if the supply of oxygen is
limited.
Now, if the supply of oxygen is little, they don't grab oxygen from air. They grab the nitrogen and they give us nitrides. Have you seen where nitrides come from?
Yes.
So the questions are here. That J is an element that belongs to period 3. So period 3 is 1, 2, 3. Where D is, it is there. And it is an alkaline earth metal. It is alkaline earth metal. Therefore, earth metals are of group 2. If it's group 2, then it is here. So that's where you find J. Now, it reacts with air to form two products. Write the equation, state the products formed, and indicate the conditions for the reaction. What is the condition? The condition is air is in plenty and then air is little. When air is in plenty, what do you form? Plenty?
Oxide.
When air is little?
Nitrides.
So equations, they are yours. You must write them. So that's what they say that who teachers give, is it 20%? The rest is you. If they tell you like that, please, you make sure you read and get more questions to answer about this work. Okay? So when projects come in senior 2 next year, make sure you lead those discussions and make sure that every group, at least, you get involved. So when these nitrides are dissolved in water, these nitrides here, magnesium nitride and calcium nitride, when you dissolve them in water and warm, ammonia gas is liberated and the alkaline solution is formed. An example is this. When magnesium nitride, magnesium 3 nitride is dissolved in water and warmed, the end product is magnesium hydroxide plus ammonia gas. Ammonia gas is written as this NH3 gas. And these are some of the common questions they can ask you. They don't show you directly, they ask you in a hidden way, like the way this one was asked here. That J is an element in period 3 and is an alkaline earth metal. You must know why it is. Then it reacts with air to form two products. Write the equation. Then from there, from the products above, they were dissolved in water. State what is observed. Write your equations of reaction. So that is how equations come. So if you fail to unlock one part, the rest you will get no mark. Is that clear?
Yes.
Good. So somebody who looked at noble gases, you can discuss with us noble gases. Noble gases, group 8 elements. Did you look at them?
Yes.
Good.
So just what's here?
Yes, you tell us what you discovered from there.
For me, I discovered that noble gases, the outermost shell is full and they are stable. So they don't react. They are inert.
They are inert, yes. Good. So they are inert. They don't react. Very good. So where are those noble gases? Give us some examples.
Argon.
Argon, yes.
Helium.
Helium.
Neon.
Neon. So there are as many as that. We have krypton, we have, there are many as you go down the group there in the periodic table. Those who have the big table, you can check. So that is their reactions. Now, all these gases you see, they have where they use them. All those ones there, those noble gases, they have where they belong. So where do they put them for those who read?
Helium is used in inflating weather balloons.
Inflating weather balloons is helium. Weather balloons.
Argon is put in
Lighting bulbs, okay. The next one. Yes. Where do you find neon?